Alrighty, my friends, we're going to make a key for this spiral review number 7. State if the two triangles are congruent. If they are, state how you know. So my choices are these ones: side, 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 angle, and angle, angle, side. Do not write side, side, angle. Do not write angle, angle. Those are not possible choices. Let's see what we got. The first one, I have a given angle, and then I have vertical angles, and then a side. So an angle, and a side. So yes, they are congruent. Angle, angle, side. The next one, I have a side, I have an angle over here, and then I have a side because of reflexive. So you might think side, angle, side, but that angle is not in between. It would need to be over here. So since that is not the case, this is more like the side, side, angle thing, but I can't use that one. So these are not congruent. Or they don't have to be congruent. They could be congruent, but they don't have to be congruent. This next one, I have an angle, a side, and an angle. And because this is vertical, that's also a right angle. So angle, side, angle for that one. In this one, I have a side, an angle, and then a side. So side, angle, side for that one. State what additional information is required to know the triangles are congruent. So we want to know these triangles are congruent by angle, side, angle. I get a side by KL is congruent to KL. So I need this angle over here and over here. So that's going to be angle JLK is congruent to angle ZKL. ZKL. If I get that additional angle from each one, then I can show the triangles are congruent by angle, side, angle. Last one. So I have reflexive there. I want to show by side, side, side. So I have a side and I have a side, but I need another one. So I'm going to get my third one from here. So that's going to be WX is congruent to XJ is what I need, or JX. And then I can prove that the triangles are congruent by side, side, side. Now here, identify the location of the requested points after a dilation of scale factor 1/2 centered at the origin. I'm going to write down the original location of those points. So A is originally at, it's tough to tell in this graph, but it looks like 2, 2. Some of the grid lines came out weird. And then B, I'm just asked about A, B, C, so I'm just going to deal with those. B is at 4, 4. And then C is at 8, 2. So, I don't even need the picture. If I can write down the points, then I can figure this out. So if that's where things are, scale factor of 1/2 centered at the origin is going to drag everything closer. So that means A is going to go 1, 1, so that's where A prime is. B prime is going to be at 2, 2. And then C prime, it was 8, 2. It's going to be 4, 1, because I'm dividing both those pieces by 2. If I were to dilate it using a different scale factor, like 8, then I would multiply each of these by 8. So if I was doing a scale factor of 8, I just made that up, not this question, just making it up, then A would go to 16, 16, B would go to 32, 32, and C would go to 64, 16, if I had a scale factor of 8. Ooh, this next one, I'm going to zoom in here. So I have an equation. My first move, I'm going to rewrite it actually. So I have 4x minus 2 over 3x plus 5 equals 4 over 5. My first move is going to be multiplied by 3x plus 5. There's parentheses there, so 3x plus 5. It's over 1. Those will cancel on that side. That's why I'm going to do it, because I want to get the 3x plus 5 off of the bottom, because that makes me uncomfortable. And so then I'm going to have 4x minus 2. I'm going to go ahead and distribute this 4. Or pew-pew! So that's 12x plus 20. This is still divided by 5. So I'm going to go ahead, there are a variety of things I could do right now, but I'm going to go ahead and multiply both sides by 5. Put parentheses here so I make sure to pew-pew! So that's going to be 20x minus 10 is 12x plus 20. Now I'm going to go ahead and subtract 12x from both sides. So that's going to be 8x minus 10 equals 20. Then I'm going to add 10 to both sides, so 8x equals 30. And then I'm going to divide by 8. So x is 30 over 8, which I could rewrite as 15 over 4 if I want to. If you want to go decimal land, I don't suggest it, but if you do, you get 3.75. Any or all of those answers are good. Number 9, perform the indicated transformations. Write the coordinates. So we've got the D thing and then the R thing. And in words, this kindly says, rotate 270 degrees and then dilate. So I'm going to rotate and then dilate. I can do that. I'm just going to snip this. And I'm going to rotate this. So 90, 180, 270. So I'm going to draw this because that's going to help me. So I see that A is at 3, 1, 3, -1, I mean. That's where A went. B is at 6, 3. And then C is at 0, -6. And then I want to dilate a scale factor of 2/3. So I'm going to write down, so A prime is 3, -1. Yeah, I'm going to set them up as points. I was going to use a matrix, but I didn't want to confuse you. B prime is at 6, -3. And then C prime is at 0, -6. I want to multiply by 2/3. So 2/3 times 3 is 2. So that's A double prime is at 2. 2/3 times -1 is -2/3. 2/3 times 6 is 4. 2/3 times 3 we've already shown is -2. And then 2/3 of 0 is 0. And 2/3 of 6 we've already shown is 4, so -4. And I'm going to plot those in blue. So A is at 2, -2/3, so somewhere in here. A double prime. B is at 4, -2. That's where B went. And then C is at 0, -4. Beautiful. And write those there, and we're done. Here, I'll be lazy. Snip and slide. There we go. I wrote them there. I hope this was helpful. Feel free to ask questions if they arise.